Welcome. This video will explore the attributes function within Cabinet Vision. The attributes function is a key feature that allows the user to set a public variable that can modify the parameters of a cabinet from the plan and/or elevation view. This saves the user a great deal of time and enables the ability to visually confirm important cabinet parameters. The attributes function works alongside Object Tree and is a feature of Solid Advanced and Solid Ultimate. Today, I'll be working within Solid Ultimate. For this video, we'll be exploring 3 examples on how attributes can be used. Example 1 will be a backscribe being added to an upper cabinet, with our attributes addition allowing us to adjust this from both plan and elevation. Example 2 will be a downlight hole in an under panel. Attributes will warrant us the ability to adjust the diameter of the hole on the fly. And finally, example 3 will work alongside example 2, but will allow us to control the outset of said downlight hole. We will add a dado for good measure, which will be for the wiring of the downlight. To begin, we will place a standard upper 2-door located in the wall cabinet category within the object catalog. We will be creating an attribute to adjust the backscribe on this cabinet. To begin with, we need to select, then right-click the cabinet to access the cabinet's properties dialog box. Within the dialog box, the parameter tab on the ribbon bar needs to be selected. We'll add our attribute in at this level, thus we need to select the Add button. We'll need to change the style to attribute. This will allow us to create a parameter on the cabinet that will identify as an attribute. We are now presented with a box for name, description, and value. When we create an attribute, we need to give it a unique name or code that we can refer to later. The attribute name also needs to be unique and short in length to simplify recalling it later on. The U prefix is to identify that we, the user, have created this parameter. A description will be added, followed by a value. Since I would like to visually identify when this attribute takes place, I will set the value to 150mm. Once we press OK, we can scroll down in our parameter list to see that it has been created, also identified by the icon of the person. Advancing from the Assembly Properties dialog box, we can now see that our attribute has appeared to the left-hand side. We can also see that the description we entered for our attribute is what shows up next to our value. We now need to add a physical backscribe to the cabinet so that it can be linked to our attribute. To do so, we double click on our chosen cabinet and ensure that the Section tab is chosen in the ribbon bar. We can then advance to Properties, then Case. By adding a scribe value in here, it will generate a scribe parameter that we can commandeer with our new attribute. Selecting OK, we will now link the 2 parameters, one being the backscribe we just applied, the other being our custom made attribute. I would utilize the end view on the cabinet to best see the application of the scribe. Navigating to the object tree, we will look through all parameters to identify our custom attribute and the recently created backscribe. Double clicking on the SCBK or the scribe value, we can now modify the shown setting to link it with our attribute. We'll need to change the parameter from value to equation. This allows us to enter our attribute in the then box. Once we have entered in our attribute name, we can test to see if it's working. Remembering that we use 150mm as our default attribute value, we can conclude that now the test has shown this value, the attribute and backscribe have been properly linked. Returning to the drawing space, we can now see that the attribute has taken effect. We can also test the attribute to see if it will change the backscribe. We have successfully created an attribute that can modify a specific parameter on a cabinet from a public variable. A second example we will explore is being able to add a downlight to a panel.
We will apply an attribute to the panel, which will allow our custom placed downlight hole to be adjusted in diameter.
I have already created a panel by modifying an existing cabinet so that the sides, back and top are unfinished. This ensures that when I add a panel to the cabinet, it will be the only part active. This also enables the user to assign sizes for the cabinet to which the panel will abide by.
Placing this panel into the drawing space, we will now need to add our hole onto the panel, which will be linked up to an attribute later on.
We will now proceed to the CAM editor. I'll right click on the part, go down to Edit, and now I can double click on the part to enter the CAM editor. We will now place a hole at perfect center. I will change the diameter of the hole to a more noticeable size.
If desired, you may utilize Object Tree to add parametric equations to the hole to make it automatically center on this panel, or to place itself wherever you desire. Now that the hole has been added, we will need to create the hole diameter attribute, which we will link to the parameter of the hole so that we have control of the hole with our attribute value.
I need to remember to use the U underscore prefix and select short but precise names for my attribute names. We will apply this through the Assembly Properties and Parameters tab. My downlight diameter attribute is named U underscore DLD or user underscore downlight diameter.
Having both essential items being the attribute and the hole, we will now repeat what was conducted in example 1. The circle hole parameter will be tied to the attribute. To link the two together, we need to navigate through the object tree, bearing in mind that since our downlight hole is added on a specific part, we will need to advance through the parent and child structure of object tree to access the desired parameter. The dx listed on the right here represents the hole's dx or diameter. We can identify that this is the hole by the text represented under the cabinet listing in Object Tree. This dx value needs to be changed, so selecting Edit, we once again change the selection in the Parameter Edit dialog box from Value to Equation. The Then box will be filled out with the code that represents the attribute. Then the test button will be pressed to ensure that the whole dx parameter now attaches to the attribute. Our attribute has now been successfully created to adjust the downlight hole diameter. As shown here, the attribute dictates the size of the hole. The third example we will move on to is how to set the outset parameter for the hole. We will create an attribute which will control both the dado and the hole outset. As shown here, I've created a dado to accompany the hole on the panel. Next, I will need to go and create my attribute. As shown here, my attribute has been named U underscore DLO, or as my description says, downlight outset. This attribute will tie to both the hole outset and the length of the dado. It is important to note that one attribute may not be restricted to one parameter. You may tie as many parameters as you wish to a single attribute. In our plan view, if we now click on the cabinet, we can see my newly created attribute on the left hand side. Listing all attributes, we have downlight diameter, which has already been configured in step 2, and we now have downlight outset. We will now tie this to the outset of my hole and the length of the dado. Entering into the cabinet, we can now view both the dado and the hole. I have already configured the dado to situate itself exactly halfway on this panel. If you wish to do the same, you need to achieve this using Object Tree. I will now enter the panel to specifically choose the dado. Making sure I'm in the CAM editor, also in the front face, I can now view both the hole and the dado. Selecting the dado, I can view its parameters on the left hand side. The length here, or dy, is what we would like to change. We're going to click on this column, which brings up this modification button to the right. You can already identify that I have placed an equation on this by the logo up in the top here. The position Y, or how far it sits in the Y of the panel, has been modified so that it will always be half the length of the panel. To accompany this, I also added a small modification so it accounts for its own width, therefore not placing off center. Proceeding now, I'll click the 3 dots to the right hand side of the length, or dy, of the dado. Right now we can see that it's a static value. We will change this to equation, and then we can go down to the then box and place in the name or code of our attribute. Now I've entered in my attribute code, I'll go down and press test. This gives me the value of 150, which is consistent with what I placed as my attribute value. We will now do this to the placement of the hole. Selecting the hole, we see its parameters on the left hand side. Being that the dado length was 150 and it's placed exactly in the center of this hole, we can identify that we need to look for a 150 value to know that this needs to be tied to our attribute. Seen here, rather than a D value being the size of an item, it is going to be the X, Y or Z, a positional item. This 150 value, when selected, presents the modification on the right. Selecting those, we enter the parameter edit, also changing it from value to equation. We will now tie our parameter to our attribute. Testing this sees 150. Pressing OK means that both are now tied to my attribute. I can return to the screen whilst inside the cabinet and now modify the attributes to see that they have both tied to my hole and the accompanying dado. Changing the diameter works well. Let's have a look at the downlight outset. Modifying the downlight outset, we'll change it to 200mm. We can identify that things have gone wrong. The dado is correct, it is 200mm in length. We can also confirm this with the measure tool. And we'll measure how far of an outset the hole has. Currently we can identify in the top left hand corner that it has a vertical value of 100mm. This is working in the opposite fashion that we wish it to. This then identifies to me that it is placing itself off the front face of the cabinet rather than the back face. Therefore, we will need to create an equation in order to get this to align itself properly. Shown here, my hole is now correctly aligning with the dado. In the top left hand corner, let's have a look at the equation I used. My new equation reads as follows. The above item in object tree's dx value minus u underscore downlight outset. What this essentially represents is the panel's depth minus my attribute. Since the placement of the hole references the front face of the panel, this will correctly align itself with the length of my dado, or the outset from the wall. We will test this, to which it gives a value of 100. Selecting OK, we can now return, and once again test the attributes down in the bottom left hand side. Let's change the outset to 100. Now they are correctly working. We have now identified how to tie two parameters to a single downlight outset. We have now identified how to tie two parameters to a single attribute. In total, we have 3 working parameters. We have the downlight diameter, which is the diameter of the hole. We have the length of the dado, and we also have the placement of the downlight hole. Thank you very much for watching this video, and I hope you've learned a lot on how to utilize attributes.